Hey guys, this is Hadi Ataei. Welcome back to my channel. Autonomous research tools, self-driving cars, smart assistants, AI agents are everywhere. But how exactly do they work? They seem to move seamlessly between observing the world and performing complex actions. Today we're going to demystify the process and break down the core anatomy of an AI agent. It all comes down to the three integrated stages: sensing, reasoning, and action. We'll map out how real world data is converted into thought and then translated back out as tangible outcomes. Let's start with the agent's connection to the world. The first stage is sensing. This is the agent's perception layer. It needs to ingest information. Just like our eyes and ears, an agent needs inputs. So, one form of input is the text or language in general. This could be a user typing into a chatbot, with the system processes using natural language techniques. Or, physical sensors is another type of input. For robots or autonomous vehicles, this is the camera, lidar, or microphone, bringing in continuous data from the environment. Or digital data. This involves APIs, database inputs, or trigger events from other softwares. These inputs are the raw data that feeds the entire decision making engine. And let's talk about knowledge, policy, and logic. Once the data is sensed, it moves to the thinking phase. This is the core engine where the agent processes information and formulates a plan. To do this effectively, it needs three things. Number one, knowledge. The agent retrieves facts and establishes rules from its knowledge base. This context might come from internal databases or external RAG sources, providing the grounding needed to make factual decisions. Number two, policy. Every agent needs a mandate. It's defined goals, objectives, and priorities. This prevents reckless decisions by ensuring the agent's actions align with its intended purpose, like adhering to a budget or prioritizing safety. Number three, reasoning and planning. This is where the logic happens. Well, the agent uses if then else rules, but it also engages in complex task decomposition, breaking a high level goal like prepare dinner into smaller manageable steps like chop vegetables, boil water. This planning relies heavily on machine learning for pattern recognition and large language models for complex multi-step thought process. Finally, the system moves to action. This is the generative part, where the internal decision affects the external world. The output could be text or speech, sending a message back to the user, or for a physical system, it involves executing control commands via actuators. For our self-driving car, this means adjusting the throttle or changing lanes. The decision from the thinking stage is now applied in the real world. Crucially, all three stages are connected by a feedback loop. The agent must constantly evaluate its own performance against the goals. Did the action work? This is how it learns. Sometimes it's reinforcement learning, where the agent sees an action got it closer to the objective. Other times, it's human feedback, where a user gives a thumbs up or thumbs down to continually refine and personalize the system. Let's quickly tie this together with our travel booking example. The sensing input is my destination and date. The thinking process pulls my preferred airlines, um, the knowledge that we have, checks my company's spending limit, which is the policy, and then reasons out the cheapest and best itinerary. The action is the direct booking with the external airline and hotel system, and the feedback is my post trip survey, making the next booking even smarter. I hope you now not only understand this three-part anatomy, but also see the immense potential these AI agents possess to improve efficiency and free you up from the routine details. Thanks for watching. Don't forget to like the video and subscribe to my channel, and I'll see you in the next video. Take care.